Hello students, in the last sessions we have seen how to calculate the combined mean and shortcut for the mean. Also we have seen the median and how to calculate the median in case of the raw data and in case of the group data. Let's see some merits and demerits of the mean. Merits and demerits of the median. Median is not influenced by extreme value because it's positional average. So if there are the opponent classes, though we can find out the median. Median can be calculated in case of the distribution with the opponent intervals. Median can be located even if the data are incomplete. Now the demerits of the median. A slight change in the series may bring drastic change in the median value. In case of even numbers of atoms or continuous series, median is estimated value other than any value in the series. It is not suitable for further mathematical treatment. Expect it used in the calculating mean deviation. So we cannot further use. So we can not do further statistical treatment on the median except in calculating the mean deviation. It does not take into the account all observations. So by the median we cannot conclude about the other observations as in the mean. As the mean of the data, suppose if I have said mean of the data are of your data is 90, that means you have the aggregate marks around the 90. But we cannot say, if I say the median of your data is 70, then I cannot say about your other marks what they are about. So it may be 80 marks, it may be 80, 90, 99, or what, or it may be below 40, below 70, it may be 40, 30, and so based on the mean I can imagine your marks, average marks in the paper, but by using the median I cannot imagine your marks, or I cannot calculate about your marks. Now we will say the mode. The mode refers to that the value in the mode refers to that value in the distribution which occurs most frequently. It is an actual value which has the highest concentration of atom in and around it. It shows the center of concentration of frequency in a round given value. Therefore, where the purpose is to know the point of the highest concentration is preferred, it is thus a positional measure. It is important. Its important is very great in agriculture, like to find a typical height of a crop variety. Maximum source of irrigation in a region, maximum disease prone paddy variety. This is the most mode. Thus, mode is the important measures in the case of the qualitative data. Suppose here example is given. What is the example? When you have to find, suppose I have some seed and I have to say I have purchased seed from a particular agency and I want to know that the height after using that seed, what is the height of the my crop. So what will I do? I cannot do here the average height. I will find out the frequency where the most frequency of height which is the most for the crops. Or suppose I have to find a suppose I have to find a famous actor. Okay, so in the case of famous actors, I will ask to the people, I will make the frequency tally mark, I will write the names in the your variable. Suppose by variable actor A B C D, and by the tally mark, suppose I will ask first question, so which is a my favorite actor. So I will mark at A. Otherwise, if he said, then I will mark the tally mark B. So I will find out whether the maximum frequency is that which is your most favorite actor. So, or most, you can say the most favorite papers and all these things. If I have to find such qualitative data, the mode is the most appropriate measure. Then the next I will say, next, how to calculate the mode in the raw data. Here it is the For ungrouped data or series of individual observations, the mode is found by mere inspections. Means you can, if the series is given, you can find which number is repeated. So if I say find a mode for the following seed weight, 2, 10, 15, 10, 17, 8, 10, 2. So here the most repeated observation is 1, 2, 3. So the most repeated observation is 10. So in this case, the mode is 10. In some cases, mode may be absent, while in some cases, there may be more than one mode. Here, each observation is at one step 12, 10, 15, 24, 30. So this is data with the no mode. In this case, there are the mode, no, means two modes are there. You can say there is a bimodal data also. That's 7, 10, 15, 12, 7, 14, 24, 10, 7, 20, 10. In this case, the observation, this is 7 and 7, and 7, this 7 occurs three times. And also if I say about the 10, 1, 2, 3 times. So both observations have the same frequency. 7 has a frequency 3 and 10 has also frequency 3. So 7 and 10 both occurs 3 times each. So this data is the, we can say, bimodal, as the two modes are there. Group data now. We will find out how to calculate the mode in case of the group data. Now for discrete distribution, see the highest frequency corresponding the value of x is the mode. Example, find a mode for the following. Here weight of the sorghum in grams, that is x, that is 50, 65, 75, 80, 18, 95, 100. Then the number of year heads, that is 4, 6, 16, 8, 7 and 4. In this case the frequency is 16 is highest regarding to the x 75. So the maximum frequency is 16. So the corresponding x value is 75. Therefore, mode is equal to 75 grams. The next, in the how we will find a mode in the case of the continuous distribution. In the case of the continuous distribution, locate the highest frequency of the class corresponding to that frequency is called a modal class. Then apply the formula. Mode is equal to L plus Fs divided by Fp plus Fs into C, that is the height of the class. In your book, it may be the F2 upon F1 plus F2, this type of written. But as I said, the notations does not matter unless the meaning does not change. So in this case, as in the model class, as in the median also, L is the lower limit of the median class. In this case, L is the lower limit of the model class. FP. FP means frequency of the class preceding to the model class. In your book, you can say it is the F1. F1 means the frequency of the class preceding to the model class. Fs means it, in your book it might be written as F2, the frequency of the class succeeding of the model class. C is the class interval. Very simple formula rather than the median. We have seen the median formula. It is very simple compared to the median. So now next we will see the examples. Here weight of the year hairs against the same example is given 60 to 80, 80 to 100, 100 to 120, 120 to 140, 140 to 160, and the number of year hairs are given, that is the frequency 22, 38, 45, 35, 20. This is the frequency and these are the classes. So now if you observe the frequency, here is the 45 is the highest frequency. For the 45 is the highest frequency, which is belong to the class 100 to 120, and this frequency belongs to the class 100 to 120. So the model class in this case is the 100 to 120 is the model class. You have to write in your notebook, the model class is 100 to 120 is the model class. So if the model class is 100 to 120, then your lower limit, L means the lower limit of the model class. So L is equal to 100. So lower limit of the model class. Now here F. What do you mean by F? It means frequency of the model class. Here model class is 100 to 120. So frequency of the model class is the 45. Now the next is fp, means the frequency of the pre-model class, or you can say here f1, or f1 is the 38 and f2 is the 35. Very simple formula. Here it is fp and fs. We can say here f1 and f2. So you have to you have to write l plus the next, the frequency of the model class, succeeding model class, mean the next model class. So 100 plus the 35 divided by 35 plus 38, which is very easy, into 20. 20 is the class width. If you say C or H, notation may differ, C or H. So 80 minus 60, that is equal to 20. So here it is the 20. So 100 plus, very simple formula, 100, you just have to write here F1 or F2, F1, F2. So 100 plus, that is the next succeeding frequency, that is 100 plus 35 divided by 38 plus 35 into 20. So your answer is the 109.589. You can calculate at your home. You can see the examples from the books. Now this is all about the mode. Now we will say, now we will check the formula for the geometric mean. uh, as the mode is very easy, you can solve as many as example from the book, and let me know if you have any problems. Now move to the geometric means. What do you mean by the geometric mean? The geometric mean of a series containing n observation is the nth root of the product of the values. What do you mean by nth root? Just do not read at it. just just break up the lines so you will understand easily. The geometric mean of a series containing n observation, remember n observations are there, is the nth root. Since n observation there, we have taken the nth root of the product. Product means multiplication of the product of the values, means product of your values x1, x2, xn. So if you have taken the product, if our observation are x1, x2, xn are the observations, then if you're then we will take the geometric mean as nth root of product of observation. Understand? So my observations are 5, then my n is 5. If my observations are 10, then my n is 10. It's very simple. And then square root of, so I have taken the square root of x1, x2, xn. So here x1, x2, xn, I'm multiplying observation x1 into x2 into xn. So this square root can be written as the 1 upon n also. So if it is very easy, nowadays in the calculators, you have all have the scientific calculators, computers now. It's very easy to calculate, but uh, by the logarithmic, the calculations may more simplified. So we will take the log to the both sides to simplifying the calculations. By using the calculators, you can directly calculate, no problems. But you have to know the another method also. So taking the log both sides, that is the log of geometric mean is equal to, as we have taken the log, 1 upon n will come outside, the 1 upon n into log of x1, x2, xn. Now you have very well known about the log. You have already learned the log in the 10th standard. So log of multiplication, suppose log of a into b is equal to what? Log of a into b is equal to log of a plus log of b, correct? So we are applying the same rule here. The log of geometric mean is equal to 1 upon n log of x1, x2, xn, that is equal to 1 upon n, that is equal to log of x1 plus log of x2 plus log of xn, that is equal to, here you have to be, if the log is to the base 10, then you don't have to mention here. So log is considered as the log to the base 10. So here that is equal to summation of log of xi divided by n. So now this is the answer of the log of geometric mean. So to find out the actual geometric mean, what you do, you take the anti-log. When there is a log is there, you have to find answer, you take the anti-log. So geometric mean is equal to anti-log of summation of log of xi, anti-log of that value, that is summation of log of xi divided by n. Now for the group data. For the group data, geometric mean is equal to anti-log of summation of f into log xi divided by n. What is f? F is frequency. So again I am saying, do not make the mistake. Direct take the summation of f into log xi. No, that doesn't work. You have to make the separate columns of the frequency into log xi. You have to multiply each frequency to the log xi. I will let you know in this next example. You will understand what is the. Now the example 1. Uh, if the weights of the sorghum earbuds are 45, 60, 48, 100, 65 grams, find the geometric mean for the following data. Here the geometric means are 45, 60, 48, 100 and 65. One of the method or one of the formula is, what is the geometric mean? Geometric means is the nth root of the product of the observation. So here you can do in one way that here n is 1, 2, 3, 4, 5. So here n is equal to 5. So take the product of 45 into 60 into 48 into 100 into 65. Take the product of these observations and then find, if you get the values, then what you will do, just take the 1/10 root of 1/5 root of that observation, that is your geometric means. Let's see on the calculator. Let's see on the calculator. In this case we will see in the calculator how will it works. So here we will start with the observation 45 into 60 into 48 into 100 into 65. That is the 45 into 60 into 48 into 100 into the 65. This is my answer. Now I have to find the fifth square root of this. So I will find, that is right square root, that is fifth square root of this. So my answer is the 60.98241884. Since I will just take up to the 4 decimal, so 4 decimal is 0.96968. This is my 60.9682. This is my answer. Now we will see in the now we will see in the case of the after taking the log.